to our Tuesday discussion on a rainy Tuesday. It's going to be the first of many, many rainy days, unfortunately. But nevertheless, we're back here in our warm conference room at the RCC. And today we have a very special guest, Professor Jörg Ewald from the Hochschule Weihenstephan-Triesdorf. He came all the way here from Freising, which is like roughly an hour by train.
Yeah, it's not far.
Not too far in the north of Munich. And
Come on.
I guess you remember that last week we heard from Lisa Geres about the Berchtesgadener National Park and that they're doing long-term research there and monitoring of animal species and the impact of climate change on biodiversity. And this week we kind of follow up on the topic of last week, but we will go into higher regions of the Alps and we'll be looking at changing environments in the Bavarian mountains, and especially we'll be looking at tree line shifts due to climate change. And one special feature of this project is that it's going to be conducted with the help of citizens, which is something new. We all know that glaciers and permafrost are receding, and I don't know if you heard the news about the Südlicher Schneeferner, which is the southern Schneeferner, one of the last 5 glaciers remaining in Bavaria, which cannot be called a glacier anymore because it's just, I think, running meltwater, so to say. Mm-hmm. I think what was it called? The Bavarian Academy of Sciences announced that in this past September, so we only have 4 remaining glaciers left in Germany, so you can tell there are huge changes happening in the high altitudes of the mountains. And this project is especially looking at what does that actually do to plants. And Professor Jörg Ewald is holding a research professorship, Diversity and Functionality of Mountain Ecosystems, I think it's called. Mm-hmm. He's a botanist and vegetation scientist, and he's the project head, project lead of the subproject 6 of BAYSICS, and it's this very long, so the acronym is really smooth. The actual title is quite long, as you can tell, Bayerische Synthese und Wissenszeit, Klimaforschung, Wissenschaftskommunikation. So BAYSICS, and what this is all about, and especially the subproject 6 is about, we're going to learn from you today. We're very happy that we have you here, and everyone please help me in welcoming Jörg Ewald.
Thank you. Thank you so much for inviting me here to the Rachel Carson Center. It's a great pleasure. And BAYSICS, I'm not going to spell this out. It's a project about citizen science related to climate research. Let's leave it at that. Quite a large project. And we have the pleasure of looking at how can citizen scientists help to find out the advancement of the tree line under climate change? So the main mission of the whole project is creating knowledge. Citizen scientists gather data and they create knowledge, but also to promote the perception by the citizen scientists and the public, and something which is always important in ecology, communicating complexity. I'm giving this lecture, but I'm doing the research with my colleague Sabine Rösler. She's actually president of a nature conservation organization attached to the Alpine Club called Verein zum Schutz der Bergwelt. So she's the right person to motivate mountain hikers for this kind of work, and you can see us working there around the tree line with some citizen scientists. And now let's have a look. So tree lines are really a warhorse of bioclimatology. You probably know Humboldt, Alexander von Humboldt, and he published this very famous chart of the Chimborazo mountain in the Andes, and it's one of the most famous ecological publications, I think, and it depicted the distribution of several hundreds of plant species in the altitude of the Andes, what he thought were the altitudinal limits of these species. And this is still a very actual topic, we have our own scheme of the elevation belts in the Bavarian mountains, and this is really something which is very good for communication, and it's very tangible, and you can really communicate it to many target groups. It's easy to understand, and it's still a complex system, so you can really convey knowledge about nature with this model that was really invented by Alexander von Humboldt in the last century. This is the curve of Austria, the red one in the top, and you can see the increase of measured temperatures compiled for entire Austria, and it's compared to the blue line, which is the increase of mean temperature of the global system. And so you can see in the Alps, in Austria, but also in southern Bavaria, we are a real hotspot of climate warming. We are more than double of the global average. And the same holds true for Bavaria. We actually are very proud. We have one of the oldest mountain measurement stations. We have measurements, daily measurements, starting 1781 on Hohenpeißenberg. That's part of the Bavarian Alps, and you can see it's exactly the same curve as in Austria. It's very close actually, and you can see this tremendous increase of temperature. If you estimate it conservatively, it's 1.8 degrees since the beginning of industrialization. So that's really huge, and it's no surprise that the Bavarian glaciers are dwindling and are being declassified these days. They cannot survive under such a warm climate. What is the Citizen Science Project? It starts from another old guy called Otto Sendner, a botanist, and he, as early as 1854, influenced by the ideas of Alexander von Humboldt, the Bavarian king sent him out to find the highest positions, the highest occurrences of all plant species in Bavaria. The guy was amazing. He took a barometer with him, he measured all the heights by himself, and he recorded 1,600 plant species and gave the highest occurrences. And for the trees, he was even more explicit. He sampled almost 500 exact positions of trees, wrote them down in his notebook, and gave the exact measured height. And we said, this is so fascinating, let's repeat this, and let's motivate hikers to go out and find those places again. And you can see in this map, you can see the brown spots are the original locations where Otto Sendner found a highest tree, a record tree, and these blue spots are all observations by 83 citizen scientists that we were able to involve in this project, and they really, within 3 years, they covered the entire Alps with this beautiful pattern. So you can see in each position somebody with their smartphone took a record and said, this is the highest tree on this mountain. The highest tree of 22 tree species we considered here. And now let's test your knowledge. I don't know whether you go hiking and whether you look at trees at all. Please go to menti.com and type in the code, or just take a picture of the code, and then let's have a look what the result is. What do you think, which of these 4 trees is climbing to the highest elevations? I hope it works. Let's see.
I can.
The code once again. I will tell.
And maybe also that we can see.
Please, first of all, take it. And then you should be able to select one of 4 tree species, or say, I don't know, if you don't know the tree species. Or with an international audience, this could be many that don't know these trees. We have the European beech, the spruce, the stone pine, and the rowan tree. you can see the leaves and twigs of the trees here. So maybe we will try whether you were able to vote. No, I don't see results.
Okay. Can you refresh?
Yeah.
Maybe you need to refresh.
Refresh. F5.
That's the flight mode.
Somehow I'm not getting the. I'm disappointed. Oh. Huh?
No, you don't need to sign.
There we go. And you are right. The Swiss stone pine, maybe the name is a little bit inviting to choose it, huh? Swiss. And it's actually by far the highest tree. But let's have a look at the order. European spruce is the second one in line, and the other ones were chosen just by very few of you. And actually I'm going to show you which is the exact order in the next slides. So let's go back to my presentation and continue. Here you can see according to Otto Sendner, the order of those 4 tree species. Swiss stone pine, Otto Sendner observed at 2041 meters. European spruce, his highest record was 1080.79. Rowan tree was at 1800, and the European beech was only at 1526, the highest record of Otto Sendner. And here you can see an output from the BAYSICS portal, and you can see the modern record that was observed by our citizen scientists. And you can see, except for the Swiss stone pine, it's considerably higher. I'm going to show you. We can translate this shift in elevation. If the measurement at the station Hohenpeißenberg 1.8 plus, we can translate this in an estimated maximum shift in elevation, because temperature is very, very closely related to elevation in the Alps. It's an R square of 95%, so it's really, really closely linked to elevation. And so you can see the top runner in realizing this is the rowan tree. It's really, it has, compared to Otto Sendner, it now occurs at 240 meters higher than 200 years ago. And European spruce is not much worse. These 2 tree species, they almost exactly track the warming, and they already realize their potential now. It's not, I'm not talking about a solid tree line, but single occurrences of these trees if you look for them when you go hiking. So it's maximum occurrences. The interesting thing is that the stone pine, the highest one that Otto Sendner observed, we didn't even find the highest specimen anymore, and it hasn't advanced at all. It's very conservative, so it will not be a winner of this game of the climate warming. And the European beech, very common tree in the lower elevations, that's only advancing very slowly. So what does it mean? If we look at this in ecological terms, it's striking that those species that are dispersed by wind with wings on their seeds, or that go through the gut of birds, they are dispersed really, really, really well. The same applies for maple, for example. Whereas those that are dispersed by squirrels and jays that collect heavy seeds, they do not so well. They don't seem to realize this so very well. It's not really clear, but it's a pattern that we see. So really, the majority of wind dispersed and endosaurus tree species, they really realize the climate warming and they climb up. And we have programmed this R Shiny app well, actually one of our colleagues has programmed it, and I'd like to show you what we can do with this. It allows the citizen scientists to actually track their own tree observations. So it's based on real observations, and they can zoom into this here. I'm trying to, yeah. And let's go to Zugspitze, a mountain that you all have heard of, and Schneeferner is actually. I'm looking for Schneeferner, that's here, Schachen and Rheintal. And let's see, I'm looking for spruces that are higher than 3 meters, so they are small trees. And the highest one that we have found so far in this area was here. And with this tool, you can actually model the extent. If this tree is the indicator for what a spruce can take nowadays, it could occur in this red area. And actually, this suggests that only the very top of Zugspitze mountain will be completely devoid of spruces, even under present-day conditions. And then we can model a further increase of 1 degree, of 2 degrees, and you can see the area where spruce cannot grow for climatic reasons is getting smaller and smaller. And of course you could argue there are a lot of rocks and there are no soils. We have a map, we can actually cut out those rocky soils and say, well, this is maybe not suitable for spruce, but even then a lot of the mountain actually is an habitat for spruce. Potential habitat. And spruce is really, as we saw, advancing. Okay, let's go back and come to this second poll. Please take the code. I'm sure you're going to be quick now. This is the code, this is the QR code, and answer the question, is this a good thing or a bad thing? Does it bother you? Is it something you're upset about? Of course you will be upset about climate change, but these spruces climbing higher up, is that something that you think is a problem? Because I'm not so sure about this. I would like to know. So we will see what your opinion is on that. And I hope this time I'm better. How did we do this?
Just refresh the URL.
Refresh here.
Click into the URL and then
refresh this one. Mm-hmm. Ah! Dangerous. Dangerous, beneficial, 12%, which means probably 2 people in this room, and many are not sure, and actually quite a few of you say this is not something that to worry about, or maybe it has both aspects. It could be both bad for someone, bad for somebody, good for somebody else. I interpret it like this. And actually I would have chosen neutral myself, because I'm not really decided on that. But I would like to tell you the end of this little story. I talked to a woman from the DPA, from the Deutsche Presseagentur, and showed her this tool. And she was really interested in the citizen science project. That's sexy. Journalists love that because a lot of participants, people are interested in it. But when I showed her the Zugspitze example, she made this headline from it. And it was Bild-Zeitung saying, this is the greatest disaster ever. Zugspitze will be covered by trees and we will have no free sight on the valley anymore. I was really shocked by this reaction, because I had never said that I was so bothered about it, but it shows that we are really very emotional about these things, and we always look for the disaster in something that's related to climate change. I was really impressed. My president actually gave me a phone call immediately and said, you did a great job, all the German newspapers are now writing about high sweet tea. And I said, oh, I could have done without that. Something else, the United Nations, they have an index related to the SDGs, to the Sustainable Development Goals, called the Mountain Green Cover Index. And actually my spruces are increasing the mountain green cover, and they consider that as a good thing. Actually, they're behind the scenes in the FAO and the United Nations, a discussion has started whether one should not, if trees advance above their natural limits, that should not be corrected here because it's not good, but then this whole green cover index would really be very hard to use. So you can see how ambiguous such findings can be interpreted. And I was really, really glad that about this reaction that I found just a few days ago in Süddeutsche Zeitung. An artist, Julius von Bismarck, he made an arts project which is exactly what we did, but he didn't observe a tree, but he planted it to the calculated position. And he wanted to put it as a symbol that the world is changing so rapidly, and that in this unthought of position a tree can actually live. It's still living, and he wanted to demonstrate this. I just wanted to give you this to think about, and this is my presentation. I hope it wasn't too long and we have enough time for discussing the findings and the project. Thank you very much for listening.